invading space to take control of our climate and environment. Hairnets and hygienic clothing a must here at Astrium. Hello and welcome to this week's show. Cryosat-2, Swarm, or even this one behind me, Pleiades, are high-tech satellites that can observe and report on our environment. They form part of a new fleet that it is hoped will help man predict and react to changes taking place on Earth. Changes that can still take us by surprise. Natural disasters are inevitable, but satellites can be useful in the aftermath. We'll be looking at how they helped in Haiti after the earthquake there. Helping in the cleanup, but for now at least earthquake prevention is not an option. Preparation then is largely confined to groundwork, as Gallagher Fenwick reports from California. And finally, as political pledges to curb emissions fail to make the cut, it's back to the future, with scientists looking at the possibility of filling the sky with mirrors to reflect the sunlight, or fertilising our oceans with iron in order to soak up CO2 and keep temperatures within a livable range. In the 1970s, the NASA satellite Nimbus allowed humanity to see that there was a hole in the ozone. Well, since then, a battery of satellites have been sent into outer space. Some are now being made specifically to observe our environment, melting glaciers and changes in land quality. With its shiny crumpled gold and silver metal sheets, this as yet unfinished satellite might not look like it, but when completed it'll form part of a new fleet that can send ever more precise 3D pictures from any part of the globe in record time, helping the military, but also an additional tool to understand our environment and objectively observe changes taking place.
Cryosat-2 is designed to measure very precisely the thickness of the layers of ice, and so we can measure like never before the thickness of the glacier, which is of particular interest at the poles.
It's in this quiet computer room that images from across the globe arrive, beamed down in colours that may not mean much to the common man, but which, when translated, can be useful in a variety of ways, notably to cartographers.
We can see there the coast and the fjord. These kinds of images can be very helpful in agriculture or indeed in making maps.
Satellites can increasingly be called into play after natural disasters, helping rescue workers find their way in radically changed landscapes.
The latest example was in Haiti, where we produced maps right after the earthquake. The goal was to give better information as to what roads remained open and could be travelled on. We also pointed out areas where there's a risk of landslides. Combining all the information from the satellite images can show us zones that would or would not be suitable for temporary shelters.
Meanwhile, outside of the exceptional scenarios and large-scale climate watch, on a local level, satellites are helping farmers adapt to changes in land quality. These images, for example, show how the waters in Colorado have dried up over the last 10 years. More than just pretty pictures, the satellites allow farmers to see clearly the patches of land that are drying out or lacking in minerals, meaning a targeted and minimal use of fertilisers, good for the farmer's bank balance and for the environment. Well, behind me is a model of the latest generation of weather satellites, letting us know whether we have rain, hail or shine to expect in the coming days. But satellites can also see signs of oncoming disasters. Cyclones, floods and droughts all have precursors which they can detect, allowing us humans to plan for the event. However, for now at least, technology cannot tackle all of Earth's quirks. Earthquakes, for example, remain in the realm of the unpredictable, and so precautions have to be taken from a ground level, notably in areas most at risk, like in California.
To many Californians like Kathy, getting ready for the next big earthquake is a matter of common sense.
Earthquakes are just a way of life. They happen. And so you need to you need to be smart about it. You need to be prepared.
And to her, being prepared means doing some construction work. For a few $1,000s, she had her house retrofitted, a method which consists in installing plywood under the structure to avoid violent motions during a quake. The lowest wooden part of the frame is also bolted to the foundation, but the builder warns that results are never guaranteed.
We never claim that any structure is going to be earthquake-proof, and we can't really put a number on what size earthquake it can withstand, because it depends on so many different factors.
Making sure that California's buildings, but also its residents, are ready for the next big earthquake is the goal of many organizations like the Southern California Earthquake Center. These professors are busy sharing knowledge about quakes. Nonetheless, they're always ready to cope with danger.
And so we can say things like, for example, over the next 30 years, there's a 50% chance that there will be a magnitude 7.5 or greater earthquake in the state of California. So we can operate over those time lengths. We're not at the point in earthquake science where we can say an earthquake will occur in this place and it will be this size and it will happen on this day and this time.
While most Californians are awaiting the next big one, a destructive quake, the Red Cross in Los Angeles is teaching volunteer students about basic earthquake survival skills.
Hold on, okay? You want to drop under a table, preferably a hard surface.
The end of the hallway is where the crisis room sits. This is where the local Red Cross will coordinate its relief operations if a disaster occurs in or near Los Angeles.
Well, California lies on an earthquake-prone zone, and so it's not a question of if, but when the big one will strike. So while locals and rescue workers there prepare for that, internationally the environmental challenge is to tackle climate change. The latest weapon in that battle, geoengineering, putting giant space mirrors or artificial trees on the front line.
Once upon a time, when people got too hot, they'd pull down the blinds. An action the planet could one day imitate to protect itself from the sun. The idea may sound like science fiction, but it's the work of one astronomer specialised in optics. To slow down global warming, he'd like to deflect sunlight by setting up a gigantic parasol made up of little mirrors.
As the sunlight comes through, it just has to be deflected a couple of degrees so that it misses the Earth.
16,000 mirrors would be needed to pull off the project. That, and finding a means of transport to get them to their final destination, some 1.5 million kilometres away from the Earth. Another unusual scheme would involve the production of a carbon-hungry seaweed. Put a few tons of ferrous sulfate into the ocean and watch the forest grow. In theory.
The reaction of the Southern Ocean phytoplankton to iron fertilization. By fertilizing it with iron and with the hope of taking up CO2 and cooling the planet.
Except that when the seaweed dies, it frees the carbon dioxide it ingested, sending it back out into the atmosphere. Also, the side effects of such a giant cocktail are hard to foresee. Another option would involve whitening clouds. A special boat would send tiny seawater particles into the atmosphere. The effect would be to thicken the clouds, making them whiter to better reflect the sun's rays. But the sea isn't the only land of environmental opportunity. Roads could soon be lined with synthetic trees, with branches that trap and store carbon emissions. According to their inventor, each tree could trap some 90,000 tons of carbon dioxide. Another large expanse just waiting to be made use of is the desert. It's thought that covering just 1% of its surface with solar panels could take care of the whole world's energy needs. Whatever the dream, all scientists agree on one point. There's no such thing as a quick miracle fix for over a century of human error. The climate is fragile and should be handled with care.
Well, it's time to come back down to Earth now. That brings us to the end of this edition of Environment. I hope you enjoyed, and I'll see you again next time.